All right, let's get into it. Today we're tackling one of the biggest, most heated debates in all of software engineering, monoliths versus microservices. It's a story that's got everything, hype, some really painful lessons, and believe it or not, a surprising comeback story. So this is the big one, right? For the last decade, this question has been front and center for pretty much every developer and architect out there. Are you going to build one giant single application? Or are you going to break it all apart into dozens, maybe hundreds, of tiny little independent services? You see, for what felt like forever, the entire industry was sprinting in one direction. Microservices were the future. They were the only way to build if you were serious about scale. But as we're about to see, that idea got a serious reality check from some of the biggest names in the business, and it's led to this fascinating course correction. Now, to really get this debate, we've got to back up a second and talk about what software architecture even is. Because it's not about grabbing the shiniest new tool off the shelf. No, it's really a discipline of making choices and realizing that every single choice you make comes with a price tag. And here's the key takeaway, the thing you really need to get. Good architecture is all about wrestling with complexity by making those big, hard, foundational decisions up front. Why? Because those are the decisions that are an absolute nightmare to undo later on. It's the blueprint, the foundation of your entire house. You have to get it right. Okay, so let's meet our first contender in this fight, the classic monolith. This is the old school way of doing things, right? Everything, your user interface, your business logic, your database code, it all lives together in one big happy code base. And you know what? There's a reason people built this way. The monolith has some killer advantages, especially when you're just getting a project off the ground. Development is super fast because all your code is just right there. Deploying is a piece of cake. You just have one thing to ship. And performance, oh, it's ridiculously fast. Communication is happening inside the computer's memory. We're talking nanoseconds here. But, and there's always a but, right? Here's where the trouble starts. Over time, if you're not super disciplined, that simple, elegant monolith starts to rot. It slowly turns into what developers call, very lovingly, a big ball of mud. It's this tangled nightmare where you change one tiny thing over here, and for no reason you can figure out, something totally unrelated breaks over there. And that messy ball of mud is exactly the problem that our next hero promised to solve. Microservices came onto the scene offering a new hope, a way to build huge systems and, just as importantly, scale huge teams of engineers. And the sales pitch was just incredible. I mean, listen to this. Need to handle more picture uploads? Just scale up the image service. The recommendations engine goes down. No problem. People can still buy things. Your data science team wants to use Python, but your web team loves Go? Go for it. Small, independent, two-pizza teams could own their destiny. It was a beautiful, powerful vision. Yeah, that beautiful vision, it came with a price. A really steep, hidden price that a lot of us paid without even realizing it at first. It's something people now call the microservices tax. And the crazy thing is, this isn't some new discovery. We should have known better. Decades ago, some brilliant engineers at Sun Microsystems laid out the fundamental problems in what they called the 8 fallacies of distributed computing. These are basically the laws of physics for networked systems, and you just can't cheat them. Okay, fallacy number 1, the big one. The network is reliable. Spoiler alert, it's not. Not even close. Packets get lost, cables get unplugged, routers crash. Inside a monolith, a function call just works. In the world of microservices, every single call is a prayer sent over a flaky, unpredictable network. And then there's fallacy number 2, latency is 0. Remember those nanosecond calls inside a monolith? Well, a network call, even inside the fastest data center, is measured in milliseconds. That's literally 1,000,000 times slower. 1,000,000. If your services need to talk to each other a lot to get anything done, your performance just gets obliterated. But this next one, this is the real kicker. Fallacy number 7, the cost of moving data around is 0. It is so not 0. It costs real CPU power, it eats up real network bandwidth, and it costs real money to wrap up data, ship it across the wire, and unwrap it on the other side. And ignoring this one fallacy led to one of the most jaw-dropping reversals in recent tech. And if you want a perfect real-world example of this, just look at what happened with Amazon Prime Video. Their team that monitors video quality built this amazing state-of-the-art system. It was all serverless, all microservices, like right out of a textbook on modern architecture. The problem? The sheer cost of shuffling all that video data between all those little services was astronomical. So what did they do? Something that sounded crazy at the time. They scrapped the whole microservices thing and rebuilt it as you guessed it, a simple monolith. And the result? A 90% drop in their infrastructure costs. Just let that number sink in for a second. 90%. That's how punishing that microservices tax can be. Okay, so at this point, you might be thinking, great, so monoliths turn to mud and microservices cost a fortune. What am I supposed to do? Well, it turns out the answer isn't about picking one or the other. The real solution is about a much deeper principle of just good software design. The answer, it turns out, is to stop thinking about technology first. It's this idea called domain-driven design, or DDD for short. And the whole point is to model your code around how your business actually works, to identify the different parts of your business, like sales, shipping, or inventory, and draw really sharp, clear lines between them in your code. This is a fantastic way to think about it. Ask yourself, what even is a product? Well, if you work on the product catalog, a product is a title, a description, a photo. But if you work in the shipping department, you don't care about the photo. A product is a weight, a set of dimensions, maybe a hazardous material class. DDD teaches us to stop trying to build one giant, all-knowing product and instead build smaller, focused models for each business context. It's this clarity that saves you from chaos. You want to see this whole story play out in one company? Look at Uber. It's the perfect case study. They started with a monolith, which let them grow super fast in one city. Then, to handle insane global growth, they exploded into thousands of microservices, and it became a complex nightmare. So what are they doing now? They're grouping all those services into larger domains that map to the business. They're putting boundaries back in to restore sanity. All right, so let's wrap this up. What's the big lesson here? The goal isn't to find the one true right architecture. It's to understand that everything is a trade-off, and your job is to choose the path that is the least wrong for what you're trying to build today. So here's the bottom line. For most of you, starting out, a modular monolith is probably your best bet. That means you build one application, but you're super disciplined about creating those clean internal boundaries using the DDD principles we talked about. You should only reach for microservices when you have a very specific, very painful scaling problem. And honestly, it's usually a problem of scaling your teams, not your tech. And no matter what, those clear business boundaries are the one thing you absolutely cannot skip. And that really gets to the heart of it, doesn't it? Being a great architect isn't about chasing perfection or jumping on the latest trend. It's a craft. It's about being a pragmatist, understanding the costs of every decision, and choosing the path that makes the most sense for your project, your team, and your business. Right here, right now. It's all about finding that least wrong answer.